Here's our lesson on doing transformations of sine and cosine graphs. So if you look at the format that I have over here, this one here, it's very similar to our transformations unit. There are specific names to describe the transformations when we're dealing with sine and cosine graphs. So the A stands for amplitude, and that would be the stretch in your y values. Your frequency is related to your period, but this will horizontally stretch or compress your graph. The C here is your horizontal shift, so that is moving left and right. And then lastly, D is your vertical shift moving up and down. So if you take a look at the diagram, it kind of tells you what the C, the A, the B, and the D could do to your sine or cosine graph. So if you look at the phase shift, C, this is just saying you can move it to the right or to the left. The amplitude is kind of your middle line and how high you would go from that middle line, or how low do you go from your middle line. Your vertical shift is moving that middle line up or down. And your period, which is also related to your frequency, it tells you how you're going to horizontally stretch or compress your graph. So we just talked about those definitions here, and I did say there is a relationship between the period and the frequency. So here is that relationship. The period of your graph is equal to 2 pi divided by frequency. So we're going to do that calculation just below here. First, we're going to determine the amplitude of y equals 3 cos x. Because there's the 3 in the front, that is where your amplitude is located. So that means we're going to stretch our graph by 3. So your amplitude is 3. Your amplitude for y equals negative a half sine x is then going to be negative a half. You're going to reflect over the x-axis, and then you're going to stretch by a half or compress by 2 vertically. And then our last example, B, describes the period. So you want to find the period when we're given the frequency. The frequency is located right on the inside, right next to the x, and we don't have anything right now. So you're going to assume that it's 1. So for y equals sine x, if you want to look for the period, it'd be 2 pi divided by frequency. And because there's no number in there by the x, we just assume it's a 1. So your period then is 2 pi, which makes sense because y equals sine x has a period of 2 pi. Now looking at y equals tan of x over 6. So I can rewrite this actually as 1 over 6 times x. It means the same thing. So that means my frequency is 1 over 6. When we have a fraction divided by a fraction, we just reciprocate the second fraction and change it to multiplication. So this would be 12 pi as our period. For C, it says determined the phase shift of y equals tan of x plus pi over 2. This plus means we're going to go to the left. And this is how much we're going to go to the left by. So that's pi over 2 to the left, just like our transformations unit. Now let's get to some graphing. It says sketch y equals tan x and y equals tan of x plus pi over 2. For tan x, we're not going to do much with it. All we're going to really do is either move our graph left or right, or maybe even up or down, but that's not very common as well. Most of the times we're going to do transformations on cos and sine, but I do want to do one example with you here just in case you ever have to do some transformations for tan. So we're going to graph tan x first. I'm just going to graph maybe 2 periods of it. Start off by graphing the x and y axes, and then putting in my scale. So we're going to go up by pi over 2. In each increment. All right. So you should have the shape of the graph memorized. You're going to have asymptotes at negative pi over 2 and pi over 2. And if you didn't have them memorized, then you just need to figure it out. So one is tan undefined. It's undefined at negative pi over 2 and pi over 2. That occurs when cosine is 0 because we can't divide by 0. So if you had your unit circle at least memorized, you could eventually figure out when tan x is undefined. Okay, so those are our asymptotes. And then we're going to have a point at 0, 0, and it's an increasing function. So on the left-hand side, we're going to go towards negative infinity. Right-hand side, we're going to go towards infinity. That's one period of it. You could also draw another one. So your next one's at 3 pi over 2 for the asymptote. You're going to have a 0 at pi, and it's an increasing function. So I just drew 3 periods of this graph. If you wanted to, you could just draw 1 period. Usually 1 period is enough unless the question tells you to draw more. Okay, so moving on to y equals tan of x plus pi over 2. So again, I'm going to start off by drawing my x and y axes and drawing in my increments. Okay, so we're going to take our point 0, 0 and then move it pi over 2 to the left. So that means we have a point here. I could also look at my pi over 2 asymptote. I'm going to move that pi over 2 to the left. So now it's going to be at the y-axis instead. Also, I'll look at negative pi over 2 asymptote originally and move it pi over 2 to the left, so now it's going to be at negative pi. This is still going to be an increasing function. That doesn't change because all we did is move the graph to the left. So here is 1 period of y equals tan of x plus pi over 2. If you want to draw one more, then you're going to have an asymptote at pi, 0 at pi over 2, and draw your arms accordingly. So this is 2 periods of y equals tan of x plus pi over 2. I'm just going to leave it like that. Now let's try a trickier one, which is your cosine. I'm going to start off by drawing y equals cos x. You should have this graph memorized by now. Your max is going to be at 1. Your minimum is going to be at negative 1, and again, I'm going to draw in increments of pi over 2. So I'm going to spread this out a little bit more so I don't have to crunch everything together. So how I like to start off by drawing y equals cos x is drawing the top of the hill that's located at 0, 1. And then you're going to go down from there. So we're going to stop at pi over 2 on our way down. Then we're going to go to our minimum at x equals pi, come back up to 3 pi over 2 as 0, and then hit the maximum again at 2 pi. This is 1 full period. Remember, a period displays the graph without repetition. So if I were to continue drawing this graph, I could. It's just going to be drawing more than a period, which is fine. It'll look something like this. And you're going to see that the pattern is going to continue on the left-hand side. So that is your parent function. That is the function that has no transformations acted upon it. So I'm going to draw the next one then, which is y equals 2 cos x. The difference between y equals cos x and the y equals 2 cos x is your amplitude changed to 2, which means we're stretching the graph by a factor of 2. Again, I'm going to draw my x and y axes first. Also note the spacing that I'm putting in between each of our values in the x-axis. I have seen students made a mistake on the scale. So if you're going to go up by 2, you're going to have to consistently go up by 2 in terms of the spaces. Make sure you don't put pi here and then 3 pi over 2 here, because then you have inaccurate spacing. Okay. So now, looking to graph y equals 2 cos x, the only difference here is the height of our graph, and our minimum maximum are going to change as well. So instead, usually it'd be at 0, 1 as our starting point. Because I'm stretching vertically by 2, is going to be at 0, 2 instead. Our zeros don't change here, but your max and min do. Okay, so this is one full period of y equals 2 cos x. And again, if you wanted to continue on with this graph, it's going to look something like this, which is the same sort of pattern as what we had before. So again, if you have an amplitude of 2, all you're doing is stretching your graph vertically by 2. So your maximum is going to increase by 2, your minimum is going to increase by 2 as well. So in words, if you want to describe this transformation, we can just say stretch vertically by 2. The next one we're going to try is y equals cos 2x. So this cos 2x, this 2x part tells you about your frequency. So on the side here we say f for frequency is 2. Now, the frequency is not really enough to give us information for us to graph this, so we're going to change this into period, which is 2 pi over frequency. And our frequency was 2, so therefore our period is pi. That means I need to compress our graph so that it fits in a period of pi. So I'm going to start off by drawing my x and y axes first. Can draw it in the same increments. There's no change to the amplitude, so your maximum should still be 1 and -1. Okay, so before when we drew our graph, we would start here, and we can still start here. That's fine. But when I finished at 2 pi. So it went down and back up by 2 pi because our period was 2 pi. In this case, our period is pi, so it needs to start and end at pi. So I'm going to start my original place, but I'm going to compress it so I end the entire pattern by pi. So that means I'm going to stop at pi over 4 as a 0. My minimum is going to be at pi over 2. Here's my other 0. And here is our one period of this graph. And you could have continued. So that means you would have another point, like the top hump at 2 pi, and you could have continued this graph, which would look something like this. So if we did a comparison between this graph and our original y equals cos x graph, you can see that it's been compressed horizontally. And that's what you would say in words if you were to describe the transformation. Horizontally compressed by 2. You could also say horizontally stretched by half if you wanted to. And our last one is y equals cos of x minus 2. Sorry, that is a typo. It should have been pi over 2, so change that. So what we're actually going to do is do cos of x minus pi over 2. It's very similar to the one we did with tan of x plus pi over 2, but we have x minus pi over 2, which means we're going to shift everything to the right by pi over 2. I'm going to start off again by drawing my x and y axes. And labeling our x-axis. Okay, so usually we would have a point at 0, 1. But because I need to shift everything to the right by pi over 2, I'm not going to start here now, I'm actually going to start here. So I just shifted over our original point over by pi over 2. And that's all we really need to consider and follow the same pattern as before. So I'm going to have a 0 because I want to go down at pi. Then we're going to go down to our minimum at x equals 3 pi over 2 and then come back up. So this is not one full period. So if I want to draw the full period, I'm going to draw a point at 0, 0. And that is our graph for y equals cos of x minus pi over 2. So here we moved pi over 2 to the right. I want you to think about what this graph looks like. Does this look like a familiar graph to us? Well, it should, because this is exactly the same graph as y equals sine x. So that's how a cosine graph and a sine graph can look like each other if we apply some transformations on it. So to end our lesson, we're going to do a try it yourself. I want you to sketch y equals cos x, y equals 3 cos x, y equals cos of 3x, and then I want you to change this to pi over 3. So go ahead and do that, and then when you're ready, please press play for the final solution. Alright, so for our y equals cos x, I'm just going to say they can refer back to our original question because we already did that before. Y equals cos x is over here for e. That was the first graph we drew. So you can just leave that one. I'm going to draw y equals 3 cos x on this graph. And I only gave you 2 pieces of graph, so you're going to have to draw them on top of each other. I'm going to draw y equals cos 3x first, and then on the same graph or grid, I'm going to draw y equals cos 3x. So for y equals 3 cos x, your amplitude just changes. Your increments in your x and y, increments in your x values don't change. Okay, so for y equals 3 cos x, usually we start at 0, 1, but instead I'm going to start at 0, 3 just because of our amplitude. And then we go down the hill, hit the minimum at y equals -3, come back up, and finish at x equals 2 pi for the full period. Okay, so that's a graph of y equals 3 cos x. Now I'm going to draw the other graph. For our next graph, we have y equals cos of 3x. This describes our frequency, so frequency is 3. I want to find the period. This is going to be 2 pi over 3. So that means I need to finish from the start of a period to the end of the period within a length of 2 pi over 3. I'm actually not going to draw on the same grid just because we had to go by increments of pi over 3. So I'm going to draw a new one here and go up by pi over 3 instead. So from start to finish, I need to start from zero, 1 as we usually would, but I'm going to end at 2 pi over 3. This does have to be an even looking graph, so in here I am going to put in a point for our 0, then we're going to hit our minimum and then come back up. This is one period of y equals cos of 3x. So again, we want to start and finish between 0 to 2 pi over 3. Then for our very last graph, y equals x plus pi over 3, we're going to shift our graph pi over 3 to the left. So usually we would start here. Here we'll change this color so you can see a bit better. Use a really different color. Let's see, green. So usually we would start right here at 0, 1, but because I'm moving pi over 3 to the left, I'm going to start here instead. And I do need to finish this within 2 pi, so I'm going to end over here because that's the distance between negative pi over 3 to just before 2 pi. That's going to be one full period. So I need to start here and end here. Now for our increments in between negative pi over 3 to our very last point, this is going to be kind of the middle of it, and that's where our minimum is going to be. And you can even count it. That's 1, 2, 3 spaces, 1, 2, 3 spaces. So that's like the middle of the start and the finish. And that means we're going to have some point in between for our 0. So you think of we have 1, 2, 3 here. And the middle of that would be 1.5. So it's going to occur over here. Same thing, 1, 2, 3, and it'll occur at 1.5, so it might be somewhere around here. Connect our points, and there is one full period of y equals cos